Hi class, we are going to talk about the product rule and quotient rule for differentiation today. So what is product rule and quotient rule, and when do we use product rule and quotient rule? So it is something to help us to like the chain rule, like it's when we're trying to it's just like the chain rule yesterday we learned. We're trying to differentiate composite function without expanding things and without trying to do more operations on that, and we can directly differentiate that. So for chain rule, we have two formulas. If we have y equals to f of gx, and then dy dx will be derived inside and then derive the outer function, but we still remain the gx inside. That's the first one for chain rule. And the second one is a special form of the first one. So if we have gx, then to the power of n, so dy dx will be bring the power down of the n and derive inside, and then we reduce the power by 1. Okay, that's the chain rule we learned. So we're trying to deal with composite function without expanding, without doing further operations, and we can directly derive that. And that's the two formulas we use. Then we talk about the product rule. Product rule is when you have two functions times together. Okay, so for example, we have x plus 1 times 2x plus 2. Well, let's say 2x plus 3. Then what we do before is we expand that quadratic and then derive from that. But now actually we can just derive it directly by using the product rule formula. So what is the product rule? So if we have u times vx, then the derivative will be you remain the ux and derive vx, and then you remain the vx and derive the ux, and then you plus that. So which means you have ux, u dash x, vx, and v dash x. You will cross multiply them and add them together. That will be the differentiation of the two functions like that times together. So we have the product rule here, and also we have the quotient rule here. We have the quotient rule here. So the quotient rule is when two functions divide together. So we have ux divided by vx. Okay, ux divided by vx. So what we will do is we make the bottom to the power of 2. Okay, quotient rule is a very complex formula. Okay, quotient rule is a very complex formula. So it's the bottom, like if it's ux divided by vx, vx needs to be power of 2 first, like the bottom is squared, gets squared. And then we bring the vx up, and then we derive the top, times them together, and minus, you swap the derivative, then you derive the vx first, and then times the ux. You need to care about the order. Okay, you need to care about the order. So because it's a minus, it doesn't like the product rule. The product rule, you have a plus, so it can just derive one times the original of the other one and then plus them. But for the quotient rule, you need to think about which one in the front. So how I memorize this is I will bring this vx up first, so you will keep the vx first, then we just derive the top first, and minus derive the bottom times the original function of the top. So that's the quotient rule. Okay, that's the quotient rule. So just have a look at the example below here. If we have hx equals to 4x to the power of 4 times 5x square root 5x, so we can say ux is 4x to the power of 4, and then we can say vx is 5x to the power of a half. Therefore, u dash x, okay, because that's the product rule, we use the product to find the derivative, is one function times another function. Then u dash x will be 16x to the power of 3, and then v dash x will be 5 power of half, and then sorry, that's not correct. So that's we'll use the what is called chain rule, what we used yesterday. Okay, we bring the half down first, and then we derive the inside, and then we reduce the power by 1. Okay, we bring the half here and derive the inside, and then reduce the power by 1. So which is, then we find the ux, u dash x, vx, and v dash x, and then we will cross times them and add them together. So we have h dash x equals to 4x to the power 4 times 5 on 2. Okay, vx is 5 on 2 times 5x to the power of negative half, and then plus, okay, that one is just square root 5x times 16x to the power of 3. And then trying to simplify that a little bit. Okay, that 2 and that go that, and then we have 5x to the power of 4. That's 5x to the power of 4. Okay, this 2 will make 10. Okay, it's 10x to the power of 4 over, that's a square root 5x, and then plus 16x cubed square root 5x. Okay, that's how we use the product rule. Okay, that's how we use the product rule. And then we will think that one, okay, because those two will be quotient rule. Okay, something divided by something, something divided by something. So let's think about the product rule again. Okay, let's just have a look at that. If we say ux will be 3x minus 1 squared, and then vx will be x plus 2 to the power of 3, then u dash x is, okay, chain rule, use chain rule, bring the 2 down, and then we have derived inside, which is the 3, and then reduce the power by 1. That will be to the power of 1. What that equals to is, that's a 6, that's an 18x minus 6. If you simplify it, that's the 18x minus 6. 6 times 3 is 18, 18x and minus 6. And then v dash x equals to 3. And then derive inside, what we have is a 1. And then times x plus 2, then to the power of 2. Okay, bring the power down, derive inside, and then reduce that power by 1. So we'll cross multiply them and add them together. So f dash x equals to, okay, let's go that side first, 3x plus 2 squared times 3x minus 1 squared, and plus, okay, what I can do here is 18x minus 6, and then x plus 2 cubed. Okay, you can leave your answer like that. You don't need, you're not necessary to simplify that further. So you can have a think, if we do that before without learning the quotient rule, product rule, what we need to do is expand that one, and then just further expand those two and trying to derive one by one. So it will be very difficult because you will find like 3 terms in that one, and you will find 4 terms in that one, and then you have 12 terms in total, and simplify and then derive, which is very difficult. So when we know how to do quotient product rule, you can just use the u v dash x and v u dash x method to do it. And let's have a look at the quotient rule. Okay, for the quotient rule, so we will write ux is the top one, 9x minus 1 to the power of 3. And then we'll have u dash x. So u dash x will be 3, and derive the inside, which is 9. And then you will reduce the power by 1, which gives you to the power of 2. So I will have 18 9x minus 1 squared. And then we have Vx. Okay, Vx is easy. Vx is x, and then V dash x will be 1. So K dash x. Okay, remember what we did before? We'll have Vx squared, and then Vx repeat on the top, and then U dash x minus V dash x then, and then Ux. So my K dash x will be, should write it a little bit below here, K dash x equals to, okay, so Vx squared, so it's x squared. And then we have Vx is x times U dash x. U dash x is 18 that, so it's 18x times 9x minus 1 squared. And then subtract. Okay, what you want to subtract is V dash. V dash is just a 1 times Ux. So that's Ux, so minus 9x minus 1 cubed. Okay, minus 1 cubed. Well, I can simplify that a little bit because they have 9x minus 1 as the common factor. So it's 9x minus 1 squared. And then this one have 18x. And I will minus a bracket 9x minus 1. Then over x squared. Okay, in that one, I will left with this. And in that one, I will just left 1 of the 9x minus 1. So you subtract that. And that equals to 9x minus 1 squared times, okay, subtract that, that's a 9x plus 1, and then over x squared. Okay, that's the derivative for that function. Otherwise, let's have a think what we should do. Okay, what we should do is I will expand that one. Okay, so for example, 9 to the power 3 x to the power 3 minus 3a squared b, so 3 times 81 x squared times 1, and plus 3ab squared, 3ab squared, which is 1, and then minus 1 cubed. Okay, and then divide by x. So we will just then derive them. That become power of 2, that become power of 1, and that become 27, and then that become 1 over x, so which is x to the power of negative 1. And then I will derive from that, so it's 9 to the power of 3 times 2 times x minus that number, and then plus 0, and then plus 1 times x to the power of negative 2. So that's how we'll derive it before we learn the quotient rule. So you can have a look after we learn the quotient rule. That will be a lot easier to do. Okay, let's have a look at the next one. So if you can see, we have the quotient rule. We use the quotient rule here, but don't forget there's the extra bit because it's something minus 2x. So you derive that thing minus the derivative of the 2x. So we'll do the same thing first. Okay, ux is 2x plus 1 times to the power of 3 over 2. So u dash x will be 3 over 2. Bring the power down. Derive the inside. Okay, derive the inside. And then reduce the power by 1. Okay, reduce the power by 1. So if you simplify it, that will be 3 root 2x plus 1. 3 root 2x plus 1. And then if you think about Vx, Vx is 3x minus 2, then to the power of a half. So V dash x will be a half. 3, derive the inside, and then reduce the power by 1. So if you can simplify that one, that will be a 3 over 2 square root 3x minus 2. Okay, let's think about what's g dash x. G dash x will be square the bottom. If you square the bottom, that's just a 3x minus 2. And then you will keep vx. So vx is that. So 3x minus 2 to the power of half times u dash x. So it's 3 square root 2x plus 1. And minus, now you derive the v side. So that's 3 over 2 square root 3x minus 2. Okay, that a half, I will just write in the square root form. And then times, that's the v dash x, and you times with ux. So that's ux. And don't forget, you still have a minus 2x at the back, so I'll minus 2 outside the fraction, okay? Just behind the fraction, so you minus 2 here. Now, what we'll do is, I will times 2 square root 3x minus 2 on both top and bottom of this fraction. Okay, both top and bottom of that fraction. So that one will be times by 2 square root 3x minus 2, and then you times this 2 square root 3x minus 2 on that term, and then when you time with that term, that number will just gone. So the g dash x equals 2. Okay, those two can be combined together. That's 1, and the 3 in the front, that's a 6, and 3x minus 2, and times square root 2x plus 1 minus, okay, that is a 3 bracket 2x plus 1 to the power of 3 over 2, and then over, okay, that's a 2 lots of 3x minus 2 to the power of 3 over 2. Okay, that is a 2 over 2, that is a 1 over 2, so in total it will be a 3 over 2. And then I will minus 2 here. Okay, I will minus 2 here. So that will be the simplified version. Well, I can't keep it in this form because that's a fraction over a fraction, so it's definitely not correct. So we can't leave it in this form, so we must times a 2 square root 3x minus 2 on both top and bottom of the function. When you times on the top, you need to time with that term, and you need to times with that term. Okay, that's the quotient rule. It's a very complex formula. You need to practice a lot to remember that and get used to it. Alright, let's have a look at example 2 here. Okay, for example 2, we have fx equals to gx over root x, and then we know g4 is 8 and g dash 4 is 6. So I want to know what f dash 4 equals to. So again, like yesterday's question, I need to know what is f dash x first. So what is f dash x? F dash x will be, okay, let's just still write ux and vx because you're trying to derive that function. So ux will be gx, then u dash x will just be g dash x. Vx is what, x to the power of half, then v dash x is a half x to the power of negative a half, and that equals to 1 over 2 square root x. So what's f dash x equals to? F dash x equals to, you square the bottom, you have the x. Okay, square the bottom, that's the x. And then the vx, okay, vx u dash x is those two, so it's square root x, okay, it's those two first, times g dash x, minus, okay, those two times together is gx times with 1 over 2 root x. Okay, now you want to evaluate g f dash 4. So f dash 4 is square root 4 times g dash 4 minus g4 times 1 over 2 square root 4. All the x become 4 and then over 4. So that equals to 2 times g dash 4 is 6 minus g4 is 8 times and times 1 over, that's times 1 over, that's a 4, and then over a 4 here. So what we will have is a 12 minus 2 over 4. Okay, 12 minus 2 over 4, that's 10 over 4 is 5 over 2. Okay, so f dash 4 will be 5 over 2. We need to find out what is the f dash x, and then we trying to evaluate by substitute 4 instead of x. Okay, so that is the quotient rule and product rule. That's only one page. It's a very straightforward formula, but you need to do a lot of practice to make your calculation accurate. I will upload the scheme of work for you and a skill sheet like the exercise for you. So it's not in our year 11 book. It will be from some other books. So you will try to find it, do the calculations by yourself. I will put the worksheet for you up online.